ఓకే. ఓకే. ఓకే.
అలా చెప్పండి. సో దట్ మైగ్రేషన్ ఏది నుంచి అంటే లైక్ సాస్ లో ఉన్న మోడల్స్ పై స్పార్క్ లో మైగ్రేట్ చేశాను. We actually made the same models. Mean the input and output did not change. Only the transformation and the model building using new technology called PySpark changed. Because output file should not change actually.
ఓకే. ఓకే. ఓకే.
అంటే క్లయింట్ కి ఏం డిఫరెన్స్ లేదు. డిఫరెన్స్ ఎట్లుందంటే యూజింగ్ ఇన్ టెక్నాలజీ అండ్ ఆల్సో ద కాస్ట్ ఫర్ ద టెక్నాలజీ. దేర్ ఈస్ ద చేంజ్ అండ్ ద గ్యాప్.
ఓకే. ఓకే. సరే అన్నట్టయితే నేను ఒకసారి అది అప్డేట్ చేస్తాను. మేము పాయింట్స్ కూడా నేను చూసుకుంటాను, ఎందుకంటే జస్ట్ త్వర అనాలిసిస్ కోసం పాయింట్స్ కూడా డ్రాప్ చేస్తాను. ఓకేనా? సరే కానీ
షేర్ సో ఇప్పుడు ఏంటంటే విల్ ఫోకస్ మోర్ ఆన్ ద ఇది అంటే ఐ విల్ టెల్ యూ లైక్ నిన్న ఫోల్డ్ అని మాట్లాడుకున్నాం కదా లాగా. దట్ ఈస్ యాక్చువల్లీ ఐ విల్ ఎగ్జిక్యూట్ దట్ ప్రాబ్లీ విల్ స్టార్ట్ దట్ ఫోల్డ్. అది జీరో అక్కడ ఏంటంటే మనం చేస్తాం. ఐ విల్ జస్ట్ డూ దట్ జస్ట్ ఈ 1 అని ఇచ్చినప్పుడు ఇట్ ఈస్ యాక్చువల్లీ డూయింగ్ మల్టిప్లికేషన్.
ఓకే 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 అండి.
ఇదేంటంటే టిల్ 5 వరకే చేస్తుంది, కానీ అంటే ఇంటూ 5 చేయట్లేదు అనమాట. సో ఇది చూసుకోండి, షో యూ దట్. వన్ కి అయితే ఇట్ ఈస్ డూయింగ్ మల్టిప్లికేషన్, బట్ మీరు ఇక్కడ చూసుకుంటే బట్ 5 ఫిఫ్త్ నంబర్ వరకు మాత్రమే చేస్తుంది.
మల్టిప్లికేషన్ అలాగా
124 ఇంటూ 5 చేయట్లేదు, అంటిల్ 24 వరకు 24 వరకు చేసి ఆపేస్తుంది.
ఓకే ఓకే 4 వర్క్ చేస్తుందంటారా? ఓకే
4 వరకు చేసి ఆపేస్తుంది యాక్చువల్లీ.
ఓకే 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 సరే సరేనండి. ఇప్పుడు మనకి అది ఇంపార్టెంట్ అయితే మీరు ఆల్రెడీ యూజ్ చేసే ఉంటారు కదా. ఓకే మనం తర్వాత చూసలేండి.
అంటే ఇది నేను ఎప్పుడు ఎక్కువ యూజ్ చేయలేదు, లైక్ ఐ నెవర్ యూజ్ దిస్ యాక్చువల్లీ. ఫోల్డ్ అనే ఆపరేటర్ నేను యూజ్ చేసిందే లేదు.
సరే సరే అండి.
సో అంటే నేను మీకు దీని గురించి ఫోల్డ్ బై కీ అనేది యాక్చువల్గా ఓకే, ఫోల్డ్ బై కీ అనేది ఇంకొకటి ఉంది యాక్చువల్లీ. అది ట్రై చేసి చూద్దాం యాక్చువల్లీ ఇప్పుడు. లైక్ విల్ సి వాట్ ఈస్ యాక్చువల్లీ యూసేజ్ అనేది. ఫోల్డ్ అనేది ఒక ఆపరేటర్ విల్ ట్రై టు యూజ్ ద సేమ్ ఆన్ అవర్ డేటా, లైక్ సంథింగ్ we already have. There is an operator called fold by key. A data is and I try to use this data. We'll use this particular thing, fold by key, because the fold by key we need one key and value. And any by key we need two things. One is key, one is value. So I'm creating this RDD1 as fold by key. So we'll just see how it works. Fold by key operator. So we'll use this particular fold by key operator for addition first. What it is, same, but the thing is only you are applying over ఒరే ఇదనమాట ఏంటి కీ అండ్ వాల్యూ పేర్. విల్ సీ వాట్ ఈస్ అవర్ అవుట్పుట్. సో మేబీ మీరు యూజ్ చేసుకోవాలంటే ఫోల్డ్ బై కీని వాడుకుంటారు యూజువల్లీ, బికాస్ వీ నీడ్ ఎ కీ. విల్ బీ వర్కింగ్ ఆన్ కీ వేరియబుల్స్. సో ఆ కీ వేరియబుల్స్ మీద వర్క్ చేయాలి అంటే వీ నీడ్ దీస్ కైండ్ ఆఫ్ ఇది. Hmm. There is some problem with the data actually. So it is actually adding with respect to keys actually. See, if we see our data, it is a comma 1, b comma 4, a comma 2. So it is considering a key, pulling the a keys and adding the respective values for a. So it is 1 plus 2 actually. Similarly, we could try here like giving 1. So it should do the multiplication part of it. But will not see any. I mean, we'll have only one, which is a is equal to 5, 5. Okay. 111 is this is what. So, so we'll find out these variables. But first thing is actually it is doing a 0. So which is add basically. So the rest will see like why it is behaving like this. So the first 0 comma add will add the values of all the keys actually. If you have one more the key, it will actually add into the same value. Like it is basically summing up without using sum. Fold by key, it will actually fold the entire values of A and also entire values of B and so on. So using this, you could actually achieve like summing up the values of A. For example, if you are using a transaction table where you have to make a sum of, for example, if it is a salary of employee, what is the total money for the taxing part? What is the total money he gained in the year from 2017 to 18? So you can start from March to next April to next March. So if you add each and every month, like whatever bonus, whatever allowances is got, everything for the taxation, for the income tax things, you could actually do using by fold by key. So it will add key is the employee ID and the value is the salary. So you could relate these two columns and achieve this particular thing. So is it clear about this particular part, like fold by key with the adding 0 comma add?
You got it.
I will tell you if we are using more of data uh, we are using RDD here for fold by key. If anything is there for other data structures, that is data frames and data sets, we'll see and work on that. So I will just close this. Before that, I will just publish this. So I have created one more so this is actually related to baby names like have shown. So this is the data we have currently. So it is name, first name, year of birth, and number of things like count is 9. So we'll just see what it is. what is the data having. So how many baby names were there? These things they're related to like first name, country, sex, and count. So each country, how many baby names were repeating, kind of things. With this C word, so I'm executing that into. The first line is actually, it is something with data. So our first line contains this particular thing, which is year, first name, uh, country, sex, and count. So I'm using take 5. I'm just executing that the first 5 records, including the first row, which is actually the column names. So now I'm just see we are just pulling a text file in a text file format to a RDD. So which is a little difficult to analyze that, because since we are pulling a CSV file, because we had a problem with CSV file, right? Like how to work on a CSV file. So this is how we work in RDD kind. In data frames, it is easy because each column will be turning into each column of data frame. So that is easy to manage. But in RDD, we need to think of this particular thing. This is Unicode, line Unicode we call it. Each line, when you pull from a CSV file, it will be considered as entire row as one record. Okay, so this entire row is considered as one record from starting of the first inverted comma to second inverted comma. So that is considered as one row. So we need to break this row into multiple columns using comma. So I'm just using a lambda function here to split the data. So I'm just using a line dot split here, which is a built-in operator, but I'm giving as split in the brackets. I'm giving as comma based on comma. You can use pipes also, like we saw pipes. Right? If you have pipe, you can use that as well. So I'm just using this. So it is done. So same thing, we'll see what the row contains. Now you can see it has Unicode has changed to each column. So it based on split condition, it is actually splitting the values into different columns. Now we could actually see the columns actually. We can work on the columns now. Are we clear about these steps, these 3 steps we did? Loading and splitting, and also viewing the data. Like from it was a one row, we split into 5 different rows, 5 different columns. Are we clear about this particular thing? Do you have any questions on splitting the line?
Here, if we want to skip the header row, is there an option? Or we don't have any?
No, we are not we are not skipping the header, but we can remove that particular thing for the analysis.
Okay.
We can do that.
The header also considering it as a one row, right?
Yeah, header also will be considered as one row.
Yeah, if you want to, is there a way if you want to skip the first row means we can skip, right?
Yeah, see, we will be acting our entire thing till using range. We can give one colon, right? Range one colon will take only from line one. It will avoid the zero. We saw that, right?
Okay.
So these are the things where you can avoid the first line in the file. You're getting my point, right?
Can we add that, Karthik, once? No, we have seen it. Range
See,
1, 100. Okay, but here we don't know the
I will,
count,
I,
right? How many rows are there?
I will show you. I will show you. Yeah, I will show you. No, this one I'm talking about. Talking about this operation. Range is equal to one colon. This one. This will give the entire till end of the row, right? End of the range, whatever it is.
Oh, okay. While reading, we cannot skip. While reading the file.
I will show you like how to skip. No, we are not reached that stage. I'm just in like just reading the file. I will
Okay.
show you like how to use these things and all,
Okay.
how to analyze and skip the first. For example, header will only be in one lines in some files. It will be repeating to two lines, three lines actually. So we'll see how to skip those things and all.
Okay. Go ahead.
Yeah, yeah. But in data frames, it is very easy. Like we can just provide a header is a header is equal to true. It will take care of that. But even then, in data frames, we need to skip this, like deleting the first particular row or second line. These things we can do. So those things we can do actually. So this is the I'm using the first in that particular line. I'm using lambda function to map line dot one, that is index of that particular line. You're getting that point, index of one, that is we are getting not the zeroth index, first index, that is first name. So I'm taking that, accessing that element now. We just split into different columns. In that split, I'm taking the first row, this one, first name, Garvin, Levy, Logan, Hudson. Are we clear about this? How to access the columns in a row in a RDD. So these are different operations applying on the data already loaded. So I'm just going through, like, you will have some repetitive things which we discussed in the last classes. So this is like I'm just going through, like from the data, the direct data. Since we already learned the concepts, I'm just applying these things. So are we clear how to access a column when we pull a data into RDD from a CSV file? This is how we access, like based on the index. It is just a lambda function which is line index actually, because we already split the data into things. But the same thing will not be applicable here without splitting. Here, if we apply here, our this thing will be different. We'll just show you. Okay. See here, what it is doing is actually it is pulling the null values which is existing after the CSV file, that is after the data. So we'll see what is actually 0. No. It is giving something weird values because it is not understanding what to pull from the data. So it is not understanding basically what to pull from the index. So since we are splitting that line into this particular thing, then we could apply the access the column. So this is how we are accessing the columns actually. Are we clear about this particular thing, like how to split the data and access the columns? This is just like one of the exercise where we didn't discuss about this thing. So I thought of adding this particular point, like splitting the line into different columns for a RDD. In data frames, it is straightforward. You load the data, you access whichever column you want. That's all. So shall we move on?
ఇక్కడ లైన్ ఆఫ్ వన్ ఉంది కదండి.
Yeah, that is index actually. After splitting, it is taking this Unicode.
ఓకే, ఇప్పుడు
This Unicode.
ఇప్పుడు టేక్ ఆఫ్ వన్ అన్నా కూడా లేదా ఫస్ట్ రో అన్నా కూడా మనకి అదే వస్తుంది కదండి, కాలమ్స్ అన్ని వస్తాయి కదండి.
అర్థం కాలేదండి.
ఇప్పుడు లైన్ ఆఫ్ వన్ కాకపోయినా కూడా ఇప్పుడు జస్ట్ మనకి డాట్ ఫస్ట్ అన్నా కూడా ఫస్ట్ రో వస్తుంది కదండి, స్ప్లిట్ అయ్యాక కూడా.
ఫస్ట్ రో కాదు, మనం ఇక్కడ యాక్సెస్ చేస్తుంది ఫస్ట్ కాలం. ఐ మీన్ సెకండ్ కాలం హియర్ యాక్చువల్లీ. దిస్ కాలం ఐఎమ్ యాక్సెసింగ్. ఫస్ట్ నేమ్ గార్విన్, లేవి, లోగన్. మనం రో యాక్సెస్ చేయట్లేదు లాగా కాలం యాక్సెస్ చేస్తున్నాం ఇక్కడ టేక్ ఫైల్ లో. దట్ ఇస్ ద డిఫరెన్స్ ఐఎమ్ టెల్లింగ్ యాక్చువల్లీ. See here, we are actually it is actually taking entire data into account. Okay, here first one is it is taking the first row actually, it is not taking the column.
Okay, got you. First column, okay.
Yeah, we are accessing a column in an RDD which is just pulled from a text file format, but the pulled data is actually a CSV file. Okay. So that's why we are accessing using line index. మనం లైన్ ఇండెక్స్ అని చూసుకున్నాం కదా Python లో. That I am applying here.
Okay.
It's not column, it is just maybe for your reference probably. I will add this. So it is clear now. So next is like I'm trying to use a flat map. We haven't used flat map yet. So what I'm using inside a flat map is, you can actually understand this. Like first thing, I'm creating a RDD with the range 5 to 10. That is 5, 6, 7, 8, 9. Total 5 elements. So 10 will not be seen. And using flat map, I'm just using a lambda inside a flat map. my lambda function x is first the number itself, then I'm squaring the number, then I'm cubing the number, x square and y x cube, and then collecting. So I'm just executing that. So flat map, what it does is whatever there in the function which you are defining in the flat map, it will does the same, like how you created the function lambda function x comma x square comma x cube. So with the data, it will just apply this function lambda function on that, and it will give the results. So I'm here using 5, 25, 125. So 5, then 5 square is 25, 5 cube is 125, and 6 square is 36, 6 cube is 216. So similarly, it is going on. So this flat map can be used, for example, I'm using only for here range. Same thing you could apply somewhere for the entire column to change into new columns, like adding something for that particular already existing data, or multiplying with some number, these things. Whatever the things, you can use this particular thing like flat map and the function. This is the usage of flat map actually. And then similarly, if we use map, how it looks like. See, this is what flat map means. The name itself means flat, the things in one line. Map is actually map each and every element to a tuple. Actually, each tuple it is giving. So that particular 5, 25, 125 is one list. So it is creating as one list. This is map function, using map function. Same thing using flat map, it does like continuous fashion. That is the difference. So why here the indexes of these two varies actually. If you access the index of this, index of 0 is 5, 25, 125, but index of 0 in this flat map is actually 5, only 5, not 5, 25, 125. You need to understand that as well. You're getting my point, right? Like indexes will vary for flat map and map. Any questions between flat map and map?
Okay, Karthik, ఎప్పుడు ఏది యూస్ చేస్తారు Karthik?
మనకు రిక్వైర్మెంట్ ఉన్నప్పుడు యూజ్ చేసుకుంటాం యాక్చువల్లీ. లైక్ ఫ్లాట్ మ్యాప్ ఎప్పుడు యూజ్ చేస్తామంటే వేర్ యూ వాంటెడ్ టు మేక్ ద డేటా ఇన్ ఎ కంటిన్యూస్ ఫ్యాషన్. మీకు ఇండెక్సెస్ 0 నుంచి కంటిన్యూ అవ్వాలి ఈచ్ ఎలిమెంట్, మీరు ట్రాన్స్ఫార్మ్ చేసిన ఎలిమెంట్ కూడా. సో అప్పుడు ఫ్లాట్ మ్యాప్ యూజ్ చేస్తాం. అప్లికేషన్ అని చూసుకుంటే లైక్ యూ వాంటెడ్ టు యాడ్ సంథింగ్ లైక్ ప్రిఫిక్స్ ఆర్ సఫిక్స్ అని ఉంటుంది కదా. ప్రిఫిక్స్ సంథింగ్ యాడ్ చేయాలనుకోండి ఈచ్ ఎలిమెంట్ ఆఫ్ ద కాలమ్ కి, అప్పుడు మీరు ఆ ప్రిఫిక్స్ ఇచ్చేసి ఆ పర్టికులర్ కాలమ్ ని ఎక్స్ అని, అంటే ఆ ఎలిమెంట్ ని ఎక్స్ అని తీసుకుంటాం. సో ఇట్ విల్ యాడ్ ఫర్ ఎవ్రీ అదర్ ఎలిమెంట్ ఇన్ ద లిస్ట్, అండ్ ఇట్ విల్ క్రియేట్ ఏ థింగ్ ఏంట్లాగా ఫ్లాట్ మ్యాప్ అంటే ఇట్ క్రియేట్స్ ద సేమ్ ఇండెక్స్. బట్ ఏమవుతుంది, మ్యాప్ యూస్ చేసేసరికి ఇట్ విల్ చేంజ్ ద ఇండెక్స్. మీరు ఆపరేషన్ చేసింది ఇట్ విల్ నాట్ షో, ఇట్ విల్ హోల్డ్ ద సేమ్ ఇండెక్స్. మీరు ఫ్లాట్ మ్యాప్ యూస్ చేసినప్పుడు యువర్ ఇండెక్సెస్, నంబర్ ఆఫ్ ఇండెక్సెస్ విల్ వేరీ. లైక్ ఇక్కడ మనకు ఫస్ట్ ఇఫ్ యూ టేక్ 5, 6, 7, 8 ఆర్ ఇన్ 0, జస్ట్ if you see here, our initial index for range is this. Using flat map, my indexes got changed. Correct?
Yeah, Karthik.
The number 6th index got changed by 2, like 25 and 125 came in between. But it is not the case with map. My indexes are still same. I can access my indexes using index of index. The only change is it changed into index of index. I can access a 0 index, comma, when 0 index and 1 element, I can access 25. So it changed like index of index, but it is still holding the value inside my same index actually.
Okay.
You are getting my point? So that is the main difference between like based on our application and basically మనం prefix suffix ఏదైనా చేసుకోవాలి mainly data transformation చేసుకోవాలంటే we'll use these things wherever required.
Okay, Karthik.
Yeah. So the same thing I'm adding into a data, same flat map I'm adding into a data. So it is a pipeline RDD type of that particular data, like this one. If you want to see what is the type of the data, like maybe it's a RDD or a data frame, at any given point of time, if you want to see what type it is, before doing some aggregations or transformations, you can just see what type it is holding. Spark, what it is holding, you can just type dot that data. So you will get the type of the data you are just loaded. So it is the same data.collect will give the same flat map values. And next I am just filtering out of this flat map. I am just filtering which are x modulus of 2. So which are divisible by 2. I'm just pulling that data. So we have 6 and 8, which are even numbers, which are divisible by 2. And also the corresponding squares and cubes of these elements will also be divisible by 2. So hence we are getting these two elements as output. 636, 216 and 864, 512. So this is filtering operation we are using again here. And how to find the distinct elements of the data we have. So to find that, we can use this distinct data.distinct. So it will give distinct. It is not non-repetitive items in the loop action. So it will give that particular output here. So definitely, yeah. Hello.
కార్తిక్ డిస్టింక్ట్ ఉన్నాం కదా, ఇక్కడ మనం రేంజ్ అప్లై చేయొచ్చా?
Distinct ki range apply cheyalemu endukante distinct is actually on the entire data.
Oh, sorry within the data kada. Okay, sorry.
Yeah. So here what it is doing, definitely we know that 5 6 7 8 9 are distinct numbers because our range is created as 5 6 7 8 9. So that will be appearing in the values. And if you see here, like we have a jumble of our indexes, because our indexes were created like something, and here the output is actually, it is completely different. Like 5 is somewhere at the end of the thing, 5 6 7, and 216 came as first index, these things. So this, you need not worry about these things. It is actually internal process, but the index of RDD, every RDD, it is like immutable, we know that. So it will hold the base index of each element. So this is just to see index, distinct, why we use, because to see what the distinct values we have. And there are some couple of repetitives as well, I guess. No repetitives actually. But it is jumbled across the things actually. No repetitives, but it is jumbled across different indexes using distinct. So every element is distinct in our data.distinct, and I'm just caching that. So this caching part we know, right? Like we are just caching because see, if you see here, I will just use count, then we can make the difference. So why caching means, since we apply data.distinct.collect, right, it will actually execute this data first. So it will execute this data first, and then finds the distinct. Every time it will execute. So that is why I just show you like data.distinct what it is doing. You can see that. You can see the pipeline. See here, if we see, it is actually parallelizing first, because parallelizing is nothing but creating the data, and then it is map partition by, means partition is nothing but it is splitting across itself. Like we have data, right? Like partition. This is distinct at one, and this is partitioning the data, and map partition RDD. So it is two-step process. So this particular thing, when we are using data.distinct and collect. So this is collecting actually. This part here we are collecting. So this is a DAG which is giving just like executing the entire flow. So now I am catching this particular thing. Data.cache I have done. So here we'll see what is our DAG looks like. See, we have a cache point, and it is not executing the parallelize and then mapping everything. So it is just cached the things. It is just this is green dot is actually cached, and it is giving the output as count. So this is the main advantage of caching. So once we cache it, we can make use of that particular data from that particular step. Need not execute, like you have hundreds of steps above caching data. So those steps will not be repeated again. So the time saving thing will have, and similarly same to caching, we have the same thing, like moving to a different, I mean, caching works on memory, and the other thing, like, yes, somebody has some question.
Yeah, Karthik, ఇది డాగ్ విజువలైజేషన్ ఉంది చూసారండి, అది మీకు ఫ్లో చాట్ వస్తుంది కదా పైప్ లైన్, అది మాకు చూపించండి డేటాబేస్ లాగిన్తో. ఏమన్నా సెట్టింగ్స్ అని ఏమన్నా ఎనేబుల్ చేయాలంటారా?
ఇక్కడ వ్యూకి వెళ్ళండి ఇక్కడ
అది వ్యూకి వెళ్ళిన తర్వాత ఇదంతా కిందంతా కనిపిస్తుందండి. ఇక్కడ కంప్లీటెడ్ స్టేజెస్ ఇవన్నీ కనిపిస్తున్నాయి. ఆ డాగ్ మీద క్లిక్ చేసిన తర్వాత ఏంటంటే జస్ట్ బ్లాంక్ స్పేస్, వైట్ స్పేస్ కనిపిస్తుంది అనమాట. పైప్ లైన్ అనేది రావట్లేదు.
ఓకే, బట్ ఇట్ డజంట్ మీన్ లైక్ నేనేం సెట్టింగ్స్ ఏం చేయలేదండి. లైక్ ఇట్ ఇస్ సేమ్ థింగ్ వాట్ ఎవర్ ఐఎమ్ యూజింగ్ ఫ్రమ్ ద database thing. I'm just using that. I have not changed any settings here. Yeah, it is nothing to do with any settings actually. కానీ మీరు ఎగ్జిక్యూట్ చేసే ముందు చూస్తే యూ విల్ నాట్ గెట్ ద టైం.
ఎగ్జిక్యూట్ చేసిన తర్వాతే చూసానండి.
ట్రై చేయండి, నాకు ఇప్పుడు వస్తుంది.
ఓకే ఓకే,
ఇట్ షుడ్ కమ్. Strictly speaking, it should come.
Okay.
Try now. Let's see.
Okay, you carry on. Okay, I will try it meantime and I will share it.
Yeah, మీరు try చేయండి. I'm just explaining explaining one part of.
ఓకే ఏం లేదు, ఈ లోపల నేను క్లస్టర్ క్రియేట్ చేస్తాను, అది టెర్మినేట్ అయింది.
Okay. Yeah, sure. Yeah, the other is this particular one. Checkpointing the data into a directory. So this is how we create the checkpointing. The checkpointing is actually moving into memory. The cache is something with doing with the. Checkpointing is disk, that is a hard disk. Caching is with memory. So you should understand the difference between these two. Like memory is nothing but RAM, cache is nothing but hard disk. Sorry, memory is nothing but RAM, disk is nothing but hard disk. So checkpointing will move that particular transformation of that RDD or the data frame, whatever it is, to a disk. The cache will hold the data in the memory. So you should decide, which one to hold back and in memory, which one to hold back in the disk and memory. So if it is a small data, like for example, say you just transformed a particular column and you wanted to hold that particular column into cache thing, then you could probably do that, because columns will not be too much, like it will be around 10 to 12 MB on the sample size which you have taken. But if you are taking entire data, then it is a problem to hold in memory, because it will definitely affect the performance of the system. So that is about cache and checkpoint. So same thing, union, I repeated here. I'm just quickly going through, before going to data frames, I'm just quickly going through each of the RDD operations we did till now. So this is union. Union is nothing but it will just add entire things into one particular thing. So that is what we are doing. We just created RDD1 with 1 to 10, that is 1 to 9 elements we have, and then RDD2 is 8 to 20. So here if you see this particular thing, 8 to 20 is, it will create 8, 9, 10 until 19. So here we have repetitive items, that is duplicates. So union will have duplicates. It is made for that. Union set is actually to make duplicates can repeat. But intersection, duplicates will not repeat. So intersection is actually taking, it is whichever matches between both the RDDs. So only 8 and 9 are the duplicates in both, and both RDD1 and RDD2. So it is pulling that particular thing. So rest it will ignore. Whichever repeats in both of them, it will display. Rest it will just remove. Here what I am doing is I am taking RDD1, which is 1 to 9, and I am adding 1 to each of the things, x comma 1. X is my number, and it will iterate till end of the thing. So I'm here. What I'm doing is, see, for example, you have some column, for example, one index, which line index maybe. So you are adding for that column, you are extending one more column you are adding next to that. So for doing that, you are using this particular lambda function. So this is how we add. So it will add for every element in the list, it will add this particular x comma 1, that is 1 comma 1, 2 comma 1, 3 comma 1, whatever may be the this thing, x value, it will correspondingly it will add comma 1 to the entire RDD. So if you see here, I'm creating a map of RDD2 as RDD2.map.x comma 2. So I have created x comma 2, and then I'm adding RDD1.union RDD2.collect. So if you see here, I'm using union and adding everything here. So if we add that particular thing, this is the value we get. Union of, because since I'm already doing RDD2, RDD2 transforming into x comma 2. So this is the values we have. So here we see what is it actually doing. So I'm using creating a function which does the print hello plus string of s and then RDD for each f. So we'll use this. Okay, non-type. Yeah. So you see this for each in some time. So this actually I'm creating a function uh, which is actually doing a number plus 2. It is adding number plus 2 for each and everything. My range is 10. So it is actually right from 0 to 9. Okay, this particular part range is 10. So it is actually using 0 to 9. So adding 0 plus 2 and adding 1 plus 2, 2 plus 2, 3 plus 2 until 9 plus 2 and collecting. So this is actually in a function, defining a function and doing a transformation of on a range of 10 numbers, which is 0 to 9 numbers, and adding 2 to each element. So we have used lambda before. So here I am using custom definition function. So if we change this, it will automatically change. N plus 4 will start from 4, 5, 6, 7, 8. So it is actually increasing by 4. And this is Databricks thing actually. So we were searching for files, right? How to access the data. To get from here. Okay. Currently, we have only one particular thing, that is CSV. We just loaded into the table. So this is how we can access this dbutils.fs.ls. This particular thing is only limited to Databricks. The display feature is only limited to Databricks. It will not work in any other Spark environment. So to access your files things, I'm just thought of adding this particular thing. And same with here. This is a shell command where we are using for logs in Databricks. So we can see what all logs we have here. So this is the one particular thing we have currently, standard error log for the Databricks. So till now we actually discussed whatever we did in like some of the elements like flat map and all new things, and also some are line splitting, these are new things. Apart from that, we all discussed the same things whichever we did earlier for the RDD operations. So now we are using like collect as map. This collect as map does like, it is actually, I'm creating a tuple 1, 2, 2, 3, 4 and 5, 6. So collect as map will actually map the things, tuple into a dictionary. So it will convert each and every element into a dictionary. Let's try something here. Since it is collecting it as a dictionary, it is a data structure we know, data structure of Python. I'm just creating one more element, 1, 4. So it interprets 1 as a key, right? So let's see what it interprets. So you are saying this, right? Collect as map actually creates a dictionary which actually non-repeating keys. This is very important, non-repeating keys. Since dictionary's basic structure is one key and multiple values. Values can repeat. So I will do that as well. Since we saw one particular thing here, I'll just change. It can repeat multiple values, yes. But it is taking the last value, whichever thing. Okay. This is taking last value. Collect as map will take the last existing value for that particular key. So this is how dictionary behaves. We know what is the behavior of the dictionary. This particular application we do on transaction tables. Like for example, you need to get the last transaction done. For example, you are working on e-commerce data where you want to find last transaction for each of the customer in last 1 hour. So if the customer placed 5 orders in last 1 hour, you wanted to access the last order placed by the customer. So this is the query for that. Collect as map on your data. Data.collect as map will give you the distinct last element accessed. Customer ID is our key, and the value, corresponding value, whatever the row it is appearing last, you will get the details. So that last row will have the order details of the customer which is placed recently or last transaction. So are we clear about the collect as map? This is new one we are just seeing. So this is the application. The data will be like last to accessing the last element of a particular key. So you have any questions in converting from a tuple to a dictionary? Like the behavior of the dictionary thing, or any question on collect as map?
ఎట్లా తీసుకుంది కార్తీక్ అది అవుట్పుట్ 1:4, 3:4, 5:6 అని
because we are giving as in a tuple, correct? మనం tuple లో ఇస్తున్నాము 1, 2, 3, 4, but because మనం ఫస్ట్ చూసుకున్నాం like it should be like when you are converting something into a dictionary, it should be a key and value base. That is that we know. So this is a list actually, basically list of tuples. So it is 1, 2 is a tuple, 3, 4 is a tuple, and it is a list of tuples. If you see here, this particular bracket represents a list. Inside that we have these things which are actually tuples. If you consider as each item of a list, it is each item of a list. If you access like index of this particular RDD, we create this as a RDD, and if we give index of 0, that particular RDD dot can access this in from an index. So then you will understand.
ఓకే కార్తీక్.
So I'm creating a list of tuples. I'm trying to access data 1 dot 0 dot connect. Doesn't support indexing. Okay. Krishna, it is actually accessing the indexes we cannot apply on the RDD first thing. So we can access only the things using collect like each element. If we wanted to collect range of things also will not work actually. So ఏంటంటే like dictionary first you need to understand like dictionary thing like what is the purpose of the dictionary to have only the distinct values for keys. Dictionaries cannot hold duplicates. First thing, duplicate keys. First thing is dictionaries are distinct keys. It cannot hold duplicate keys, but it can hold duplicate values. So since we have here 2 and 4, our 2 and 4 are the duplicate values for 1. So we have 2 values, that is 2 and 4 for key 1. So it interprets first element as 1 when key, second element as value. Collect as map interprets first element as 1, second element when first element as key, second element as value. So since we are, it reads this particular thing 1, 2. It reads actually, but while it going through the end of the list, this particular list, it has 1, 4. So it will replace the value of 1 with 4. Initially it has 2. So once it reaches the end of the file, it has 1, 4 as well. So it will replace that particular with 4 for the key 1. So that is the collect as map doing here. Mainly we use for this transaction tables. So to see the last transaction done by some key, there is customer or some transaction done by a particular key. So that is the thing. But we can access through list actually. Like directly if we are creating a list, then we can access this through index. But collect as map is a Spark function, not a Python function. Is it clear?
Yeah, Karthik.
So next is pair RDD. So this pair RDD is nothing but like the same thing. I'm creating a pair RDD, creating a key ABC, which is 3, value is 3, and creating def as 4, GHI is it is just ABC, DEF things. So to check the type of the RDD, we use type.pair.rdd. So this also we saw like how to see that. This is a very important thing, like checking the type whenever you have some problem with the data. You can see what type of the data we are dealing with. For example, sometimes you will be working on data frames. Suddenly, you will see a error stating that RDDs cannot be transformed using flat map or something. So in those cases, you can just see what is the type of the thing, because we are working on a data frame, we know that. But if you get such errors, there is a transformation which is actually converting the data frame into RDD. So you need to take care of that. So for using in such situations, you need to use this type and the data, whichever you are working in. I mean, whichever data you had a problem with. So here I'm just using a zip function here. Zip is nothing but like we have seen the compress files like WinRAR, WinZip, 7-zip, etc. Right? The same concept here. We are zipping the elements into one thing. So what are the elements? I mean, these are the data basically. Zipping a data into one thing. So if you use this, L1 is range of 50 to 100, L2 is range of 100 to 150. So I'm creating a RDD, which is basically zipped by 2 elements, that is L1, L2. So here what happens is it will add L1 first element, that is 50, and then L2 first element, it is 100. Second element 51, 100 on 1. So till end of 150, it does this. So this is a zipping thing, where you want to add, combine two columns into one with respective rows. Are we clear about this step? This is very important step. Like, you have two columns from two different tables. You have derived two columns from two different files. You are just joining them. This is also a type of joining things with no conditions. Just add this. So zip. Are we sure about zip? RDD. So this is the idea of zip, like with low conditions like joins or any other thing. It is just zipping the corresponding elements together. That's all. And create a new RDD. And here I'm actually using combine by key. So since we want two things actually, like one is we did the operation on combine by key over the data, like on the numerical data. Here I'm trying to do with the same thing as a text data. So I'm converting, I'm creating a same data, that is a comma 1, b comma 1, a comma 1. Then I'm creating only two keys, that is a and b, and have different values for that. In first, this is my str is my first element, which is actually the string itself, just the str, that is string. The first element is I'm just creating a string, means creating a value, that is str. So second and third, it is actually doing, we know that this will apply on partition level, this will apply on cluster level. So add is actually doing at partition level, this is actually doing that entire this. So we actually will remove this part, will create as new. Let it be. So if I execute this, in first step it is actually reading the string as a variable. Second step, it is actually returning a plus string b, that is this particular thing, and corresponding this. So it is 1 plus, not 1 plus 1, it is 1 and 1. So concatenating two things. Two strings here. So this is at the partition level and this is at cluster level. So A has 1, 2, 3, 4, 5, 6 elements. So we can just check 1, 2, 3, 4, 5, 6. So we added 6 elements of A here in the complete entire sorted. So I'm using a sorted x dot x is my data, combined by key, string is my variable, add is my first variable, function, which is actually doing a string concatenation at partition level, since we are dividing it to two partitions. Here we can see it is two partitions, and I'm doing it at particular thing, like maybe it is 4 plus 4 or 1, 2, 3, 4, 5. So 4 plus 5 it is. So this will be created into one partition. This will be into second partition. So we'll have two things here. Two partitions actually. Data is split across two partitions. In first level, it is doing concatenation in the partition 1 and partition 2, and then concatenating these two things. So we are getting the value of A is 6 ones and B is 3 ones. You can check B 1, 2, and 3. Yeah. So this is how we use combine by key. Same thing we could do using lambda functions. So this is defining functions. We usually use defining functions only. Very rarely we come across these lambda functions for numerical variables. So I will just leave it this particular thing for your your execution. I'm not executing it again here. So you can try this particular thing. I'm just doing a sum count here, doing a sum of the things using these functions. So first thing, I'm creating as a value as 1. You get these values. So since we have 2, 4, 0, 10, 20. So these are values. So you can add these things using combine by key. Try this out. This is an exercise. I will just put it as exercise. Try out this. Try to do the average also using combine by key. Again, try average here. I have some more. You can try. You can do the average as well. So these two things you need to execute. So I think I will stop it here. Tomorrow, like we'll see, like directly moving into. I think this is still RDD. Yeah, I think we'll complete this. So we'll start fresh with data frames. So I'll just complete this. So one more file we have. I'll just show you the data. See, I have only these many things here. So I'm just putting that into our RDD. So I'm just caching that. Connecting this. So this is our data here. We can just this is a reduced thing actually. The same based on this data, the data which we actually have here. This is a reduced one. We'll work on that. Like this particular thing, we'll work on this particular data set only. I have the entire data set here, which is this thing. So it is zipped one. We'll access how to when in data frames we'll access this particular first dot underscore transform CSV will directly pull into a data frame. So we'll try that as well. So I will upload these things right into the drive. You can access this. This is again line index. You know, we just did that. Sorry. Here. So here one more thing. Co-group. Yeah. We have two things. One is parallelized. The other is X co-group Y. So I'm creating two RDDs, which is X and Y. And RDD X co-group Y, it is actually creating connectors. I should get that here. RDDs here. So I'm putting that particular thing into. I will add a connect here. Hopefully not display. Sorry. So we know that Xco group will give the corresponding values which are matching with this thing. I'm creating a variable. I'm adding the connect, the RDD.collect into a variable, and then I'm accessing using indexes. So first index is I'm accessing first index 0, 1, 0. That is actually 1. So if we see here 0, 1, it is actually 1. Zeroth index is A. It is going to that particular A, and then accessing the value, corresponding value is 1. So that is 0th index in the index of index. So that is what it is actually doing. And I'm just creating a function here for summing across the numbers 1, 2, 3, 4. So here I have two partitions. So I'm using map partitions only. So I'm not using across things actually. I'm not using this particular F. This is because we're using map partition. So what is the value of my definition function F across partitions? So I'm splitting into two things. For example, I'll just explain this in detail. Wait. So here it is doing 3, 7. So 3 is first two elements. These are going into one partition, and these two are going into other partition. And sum iterator is sum of this X actually. So I'm just creating a iterator instead of X. We could have used sum of x also. So that will also work. I'm just creating a variable called iterator for our understanding. That's all. This is yield sum is it will fetch the output as like a return sum, right? That is the same thing, yield sum. So it is output of that particular sum iterator. You can use, instead of yield, you can use return also. So map partitions is nothing but this function is applied across map. So I'm just changing this here, 5 and 6, and I'm changing this to 3. So 3, 7, and 11. See, this is what it actually giving it. Are we clear about this particular function, map partition? So each part, to find out the each value in a partition, we use map partition and the functions. Are we clear?
No, Karthik.
Map partitions, and see, you forget about this. Map partition is nothing but doing a operation on map level. So here what we are doing, an operation of sum. Okay.
Okay. Got it. Yeah, it took partitions. The first partition is comma 2. It added 1 plus 3. Okay. The second.
Correct.
Okay.
This is across partitions. We saw across the cluster, right? This is across partitions.
కార్తిక్ ఇక్కడ 6 పక్కన ఇంకో 7 అనే వాల్యూ ఇవ్వండి, ఎట్లా యాడ్ చేయొచ్చు?
మీరేమొస్తుంది అనుకుంటున్నారు చెప్పండి. You interpret first before getting the value. You just interpret that.
Third partition is with 5, 6, 7.
Correct. 5 plus 6 plus 7.
18.
Yeah, Karthik.
So we'll just execute this. 5 plus 6 plus 70. It is 18. 11 plus 5 plus 6 is 11. 11 plus 7 is 8. So if we add here 4, what will be our it will be last element is 7. Or it interprets differently. So 4 is 1. It took as first element as 1, second and third as 2, and 4 and 5, and then last. So is it clear? Since we had one element, it is not a pair of elements, so it is interpreting as the first two element as 1. It will take either first or last element as 1. Here again it changed the sequence. So this is the use of a map partition. So we see across partition what is the sum we are doing it. Across cluster we saw just applying RDD.collect, it will give to then the function like mapping that particular function. That's all. Using map we can do the complete across function. So we'll just try that. RDD.map. Yes. Dot collect. Some other things also in partition. with index with split. Stage failure that most recent task local host OT. So we need to use combine by key. Plus oh sorry. Next. That was not part of task. So we'll exam. I think we should use this.
రెడ్యూస్ వాడితే వస్తుంది కదండి.
ఏం లేదా
రెడ్యూస్ అండి.
రెడ్యూస్ వస్తుంది, లైక్ we didn't touch కదా. RDD2 is equal to index. It doesn't have. So it actually does the transformation of sum, but it is not doing a print here. So I think we should use reduce. We could use naga, but మనం reduce ఇంకా ఇవి చేసుకోలేము కదా.
కాకపోతే నేనైతే దాంట్లో చూసానండి, రెడ్యూస్ ఇచ్చేసి
Yeah, red.
ఆ సెట్ మొత్తం యాడ్ అయిపోయింది అనమాట 1 by 1.
Actually flat map కూడా యూజ్ చేయొచ్చు.
అదే రైట్ ఫంక్షన్ ఏమో అనుకుంటున్నాను నేను, అటదేమో అనుకుంటున్నాను.
We can do this also. Like index మనం ఆల్రెడీ కంబైన్ బై కీలో చేసాం కదా. Replace this format. మనం యూజ్ చేయాల్సింది అయితే సేమ్ థింగ్, అదే ఇండెక్స్ యూజ్ చేశాను కదా. దట్ ఈస్ ఓన్లీ వి యూజ్ యాక్చువల్లీ ఫర్ యాడింగ్ ద ఇది ఫ్రమ్ లాంబ్డా ఫంక్షన్ యూజింగ్ మ్యాప్. సో దట్ ఇట్ ఈస్ నాట్ విల్ సీ దట్ అంటే వేరే లాంబ్డా ఫంక్షన్ చూసుకున్నాం x+1 it is working, but across this is index actually only by using combine by key we tried that. ఇది కూడా మనం will see that. I will add that. Okay, దీనికి యాడ్ చేస్తాను, you can access later. So this is map partitions. The one more example here is like splitting the index actually. So what it is doing is ఇక్కడ 1 and 2 and 3 and 4 are the 4 elements we have. Let's split index. I'm creating 2 functions here, that is split index comma sum of the iterators. So what it is doing is, it will does first these two are going into one partition. So this partition, the index will be 0. Okay, that is the split index. So that is the first partition will be accessed. So it will get this particular value of index here 0. And second thing, it is doing a sum of the iterator. Iterator is nothing but x value, that is 1 plus 2, that is 3. So this is partition with index. Partition with map partitions with index will take two variables. One is the function should have two variables. One is index value and the corresponding iteration thing. That is function. This function. It has two variables. It takes two variables. If you see here, if you want to create directly RDD, map partition with index, it takes the function, and with split also you can do, that is presuming partition. So this index will take two values. One is for the partition thing, and the partition index. The second thing is sum across that partition. So here we have sum across partition is 3 and the index of the partition is 0. So saying if we increase this 5, 6, 7, 8, and if we raise this to 4, we'll have 3 indexes, 0, 1, 2, 3, and the same value like this. The sum will be remain same, only it is added from the index 0. There is partition 0, partition 1 and partition 2. So this is from the first partition, this is from the second partition, this is from the third, and this is from the fourth partition. Since we have given 4 partitions. And here what we are doing is creating a fold function using lambda. Like yesterday, Naga, you were asking about the fold thing, right? So I'm creating as one partition this entire thing. I'm overriding because Spark will take into like maybe 2 or 3 partitions. I'm overriding as one partition. So fold is one here. It is actually what it's supposed to do is a multiplication. Basically, one refers to multiplication, but I'm using a lambda function here. We used add, right? But here I'm using lambda function x comma y and x plus y I'm using. So what it does is, it is doing 4 plus 3 is 7, 7 plus 2 is 9, 7, 7 plus 2 is 9, 9 plus 1 is 10. But the value here what we are getting is 12. So this is like increasing by a fold. So if we keep as 0, it will take the exact value of 10. So this is doing, for sum, it is doing adding the entire thing with based on this particular lambda value. So 1, 2, 3, 4, I've yet to try these things, like what it is actually, how this value, varying this value will give different results. So I need to try that, like 2, 3 years, 12. Yeah. So this is fold using inside a lambda. How to use a lambda function inside a fold. So same thing with fold by key also you can try actually. Fold by key, like you have here we have only 4 elements which are just values. You can try with key and values also, how we did in a comma 1 these things. So you can try that as well. So how to use a lambda function inside fold. So you can use any function. Not only this, you can define a function like this. F. You can just access through this particular fold. for doing aggregate here with this one, average string, to find out the average of this combined by key, you can use the concept of this. Like you can create like this thing, something like this. So here what it is doing is, it is working on the index basically, like y of 1. It is the index actually. So this is the index. So x plus 6 and 88, and then it is 99. Adding everything, you will get this value, like 90 plus, no, 40. This aggregate will take 5 elements actually, 3 elements basically. The value of the thing, one is x plus 1. Yeah, it is in first, similar to combine by key. This aggregate, what it does is it goes along 3 variables. Like this is at partition level, this is at cluster level. So it will split these things, but this 5 is actually the number of times you need to iterate. See, I think a basic thing I will need to take an example as basic one. This is not a better example. We'll execute the aggregate things tomorrow maybe. I need to get a basic one. This is little it is same as any other like combined by key thing. So it takes 3 variables basically. So first is 0 value is nothing but what extent you wanted to do this particular aggregation, and second function is across partition, and third function is across your combining the entire thing. So that is across partitions, across cluster. So 3 variables we need to give. So I'm giving as 0. Zero's value is 0, and I'm using the function of lambda x equal to x plus 1. I'm just using a simple thing. This is partition level, and this is at cluster level. It is adding 99 plus 88 plus 6 plus 4. So you will get 197 for this particular thing. But the thing is, like 5 is actually changing similar to the fold value, like how we change this into multiplication, division, these things, right? So similarly, it is varying the values of things. So I will let you know like how to use these variables in fold and aggregate tomorrow. So even I'm not sure like how to operate these functions from 0 to, I mean, how the zero value will vary, because one is for multiplication, zero for addition, one is for multiplication, but it will when we use here c dot fold 1 to use this, it will actually multiplicate till here. Fold. Fold. So it is doing the addition here, but if we give 1 here, it is actually doing multiplication till here, 3 to the 6. work on this actually. I'm not sure like why what is the zeroth value fold and aggregate does. But for the zero thing, it is actually does the addition actually. So we'll see these two things like aggregate as well as fold tomorrow. Like the 1, 2, 3, what is the variables doing? Why it is fetching us 19 and all. We'll try one. It is very general. Okay. This is very general, so no, this will not help us much. So I will let you know these two things. Like I will keep it as a note thing. These two I will just let you know tomorrow, and we'll start with the data frames from tomorrow. Like we'll start with the data frames, like how to load, how to transform, clean everything. We'll see, and then we'll probably switch into machine learning from probably next couple of classes. Is it okay?
Okay.
Just publishing this. I'll just add the files as well. The baby name files as well. So we'll work on these two things. Parallelly, you can start, once we start the data frames, probably you can also start with your data cleaning process on the all state data. So that we'll see like how you build the machine learning algorithm based on the all state data. We can try on these things. Probably maybe in another 8 days we'll finish off both machine learning as well as the data frames.
Okay.
Yeah. And Mohan and Krishna, like you have any questions on the rest of the thing apart from the fold and aggregate?
No, Karthik, I think I need to go through this recording again.
Okay. Okay. Yeah. Please go through like RDD. We have only those two to discuss, and rest we'll start with our data frames. So we'll see the data frames from tomorrow after seeing this fold and aggregate thing. So probably we'll start with RDD. Data frames from tomorrow.
Sure, Karthik.
Yeah. Bye, guys.
Fold